Okay, so yeah, it's kind of been a long time, I think like 2 weeks or something, but then again, it's better than most of my breaks. So, yeah, anyways, it's been some time and I don't remember where I saw this one, but like it was in my gallery somewhere. Anyways, yeah, this is a well, it's a question, alright. I mean, I won't say it's that good, but it's like intimidating in the sense that it's been put in a way that would scare someone, negative exponents and this stuff inside them and all that. So yeah, it may scare you, but just, you know, let's remain strong, right? Okay, so the question says that some expression and then another expression, both to the minus 2's power, are equal to 1, right? So yeah, I'm not going to speak all of that, but I think my handwriting is not bad enough for it to be not understandable. Anyways, so yeah, from here on, now I mean, you may have some more elegant approach to this, but I couldn't really think of one, right? I thought about this for quite a while and I didn't completely go through it, but I went to some extent. Anyways, so yeah. So a straightforward approach, as one may think, could be just like, simplify this stuff, both the equations. So yeah, so in the first one, right, if we, well, I guess we'll take a common denominator. In this case, it will be y. So we will multiply this by y and divide it by y. Notice that the y's cancel out, and also notice that x and y, neither of them can be 0, because then, you know, life will stop existing. Anyway, so we do that and the same spiel will happen here. So what we get is xy plus 1 upon y to the negative 2's power plus xy. Now I'm working under the reals, I assume. I'm not going to assume some weird field where multiplication is not commutative. Anyways, we're just going to, assume that yx is equal to xy. We're not working with matrices, sorry. Anyways, xy plus 1 upon x, the whole thing to the negative 2's power, is equal to 1. And we'll be doing a similar thing to the second equation, but let's go through the calculation with the first one. So we have at least like some kind of an idea, right, what we're going to do. Anyways, so now xy plus 1. So, well, notice that there's a negative power here, right? And we know that a to the minus b can be written as a to the minus 1, the whole thing to the b, which can be written as 1 upon a, the whole thing to the b's power. So we're going to use exactly that, but like our a is this. There's construction work, I can't help it, honestly. Yeah, I'll try to speak louder. So what we do is we take the reciprocal in both of these situations. So we get y upon xy plus 1. Okay, so I guess I'll just square them, right? So we're distributing the exponent inside, right? So it's 2 in this case, and similarly here we get x squared upon x plus 1 whole square. Notice that this is the same denominator, so I'm not going to waste space. I'm just going to put the both of these things under like one denominator already, whole thing squared, and this is equal to 1. Well, this very clearly implies that we can cross multiply this part, because this can never be 0 except when x times y is negative 1. Well, if x times y is negative 1, then life is interesting. Okay. I didn't really think about that. Can x times y be negative 1? Well, I guess we'll assume it's not. And if it is, then we get a different solution all the way, right? Because we're supposed to find this expression, and assuming stuff about x and y, x times y, gives us the solution directly. So anyways, ramblings aside, so we cross multiply this part of the expression, we take it to the right hand side, or I guess you could say that we multiply x y plus 1 whole squared on both the sides of the equation. Yeah, whatever way you prefer to look at it, that's fine, right? Okay, so that's what we get pretty much. Now what we could do is like open this up and all, but I don't really think that's required. Anyways, that's one of the expressions. Now for the second equation, it's a similar simplification. I don't know, I'm gonna do some of this in my head, right, just to save some space, because the construction work is stopped now and I don't want to like re-record and stuff. Oh, it started again, goodness gracious. Anyways, so I'm gonna do some of this stuff in my head. So notice that what we found is that the denominators on both of these will be the same. So for the second one, what we'll have is x squared plus y squared, and of course it's going to be a positive sign in the middle because that's just how the question is built, upon, well, x minus x y minus 1 whole squared. And now in this case the RHS is 2, so we cross multiply again to get x squared plus y squared is equal to 2 times xy minus 1 whole squared. So what we get from here is, okay, so I want you to pay attention to this equation and this equation, right? So from these we get the following, right? So we compare the two equations and we find that the RHS are equal, right hand sides are equal. So yeah, I'm gonna expand the brackets now, and okay, so here's the formula, right? A plus b, this is the binomial theorem, but like, you know, binomial theorem for dummies or something, I don't know, whatever you want to call it. So yeah, this is pretty much the formula for the sum of two, I don't know, I mean they can be complex entries too, I think. Yeah, yes, two entries. I don't know. Anyways, so yeah, so we get that this is equal to this, so I'm going to expand it out. We get xy the whole thing squared. Well, that thing is going to be plus 2xy plus 1 is equal to, now the second part, right? So this is 2 times xy the whole thing squared minus 2. Okay, so this is like a plus or minus thing, I guess I should point that out, right? Yeah, minus 2xy plus 1. This remains positive because you know the squares are always positive, and these, by the way, include the signs, the formula. So anyways, yeah, we taught this in like, I don't know, I think it's like well, let's see, freshman year of high school, I guess, I suppose, right? I don't really know how stuff is done. Anyways, so from these two equations, what we can do is we can take this thing here and we get, so we're gonna move everything to the right hand side basically. So we get 0 is equal to, well, okay, so 2xy the whole thing squared minus xy the whole thing squared. This is going to be 1 times xy the whole thing squared, right? And then moving this to this side, so there's going to be minus 4xy, and then this becomes negative as it goes here to the RHS, so it's going to be minus 6xy. And then, well, what we get is 1, and then this is 2, so it's just going to be plus 1, right? Hopefully you can follow along. Until now I don't think I've done any witchcraft as such. Anyways, now I just have some OCD, so I'm gonna switch around the right and the left hand sides, and I'm going to put brackets around something, you know, just to make it more clear what I'm doing here. So we're going to consider this part as our variable, and this, you may notice, is a quadratic equation in x times y. And how funny coincidence, that was exactly what we're supposed to find for finding what we're supposed to find. I hope you can follow along. Anyways, okay, so, well, okay, the first thing that comes to my mind is, well, maybe you should just solve for x, y, and then plug it in here. But maybe I think I should, yeah, I hadn't thought so far, right? So, okay, here's a thought I have. Maybe we should simplify this expression first. Huh? Maybe we should. So, yeah, what we get is, let's see, so let me think this through in my head. It's gonna be xy the whole thing squared plus 1, right? Now xy the whole thing squared plus 1 is equal to something. Okay, so let's just say that this has some finite value, which is why we can assign a variable to it. I mean, okay, we can assign a variable to it anytime, right? So let's define it as a, I don't know, So let's multiply both sides, right? So xy, sorry, let's take the common denominator, I meant, pardon, plus 1 is equal to, well, let's see, 6, no, not 6 actually. So upon xy, I'm just gonna write everything out. I actually had thought, no, this is actually kind of elegant if you apply some brains. So this, I'm just gonna do another step so that, you know, if someone's like slightly dyslexic or something, then they're not at a disadvantage. Okay, so assuming that what we find is a, we get the following equation in a where xy is a constant, because we already have the value of xy because we found something about it. But notice that, okay, yeah, this is actually pretty cool. Okay, this has become like a lot much cooler. I know English. Anyway, so xy, the whole thing squared, plus 1, right? So that is visible here. You can move this to this side. This is elegant. Okay, xy, the whole thing squared plus 1 is equal to 6xy. Oh my goodness, this is very elegant. Let's call this equation 1. Let's call this equation 2. And behold, ladies and gentlemen, and dogs and koalas, I respect animals. Anyways, comparing equation 1 and 2, I guess I'll just write this. 1 and 2 imply, I guess, together, they imply that axy equals 6xy. axy equals 6xy. Now I'm gonna assume that x and y, oh yeah, well, I mean, the question itself has it like inbuilt that x and y cannot be 0, so yeah, we can just cancel out x and y, which is a really terrible approach, but I guess it works out here. So 6 is equal to a, and a was exactly what we wanted to find by definition. Wow, okay, so the answer came out quite, how do I put this? Well, the answer was yeah, kind of elegant, more elegant than I thought, right? Because in the way that I thought about it was, okay, so we'll get some of this stuff, right? Up to here I thought it through, and then I was like, I'll wing it, whatever. So, and then I thought like, okay, so we'll get like similar equations, we'll compare, and then we'll solve this quadratic. But then, like, literally right now, during, this is like improvised, by the way, I just thought of this. Yeah, this is like surprisingly similar. So, you know, I guess just don't do brainless calculations. Use your human skills, I suppose. Also, the construction noise is like brilliant. I love it. It's like music to my ears, honestly. It's like I'm listening to Elton John rap or something. I don't know. Yeah, anyway, so the thing that we wanted to find is equal to 6. Yeah, let's write that out. And yeah, that's about it. Let me just think of some way that we could create well, I want some new creative way. So maybe a concatenated with 9. No, I don't think that's how you write concatenated, but I guess a 9 with a bar over it, and that becomes nice. And if you know why that's nice, then subscribe, because you should know why that's nice. So I'm gonna have more subscribers, I hope. Anyways, yeah, that's, I don't know, dude, that last part, yeah, I didn't really understand that at first. Nice. Yeah, brilliant.